I'm going to draw the picture of the normal curve. My 1, 2, 3 standard deviations above and below the mean. I could go more than that, but that's a good starting point. So we'll have the mean x bar. We'll go 1, 2, 3 each way. On that place where I wrote x bar, this would be the scores, whatever they are. X bar, 1 above would be x bar plus 1 standard deviation. 2 standard deviations above is x bar plus 2 standard deviations. 3 standard deviations above is x bar plus 3 standard deviations. And if I go the other way, 1 below is x bar minus 1 standard deviation. 2 below is x bar minus 2 standard deviations. And 3 below is x bar minus 3 standard deviations. That's a score. A z-score is this. Let's take the number line, but let's take the horizontal line and treat it like a number line. Same type of number line that you learned in elementary school. And then at some point they came through, probably around 5th, 6th, 7th, or 8th grade. And they said, you know what? There are numbers to the left of 0. Negative numbers. So we extended the number line in both directions. Where x bar is, that's a z-score of 0. So on my number line, I'll put a 0 there. The score that is 1 standard deviation above the mean has a z-score of 1. A score that's 2 above has a z-score of 2. And a score that's 3 above has a z-score of 3. Can you guess the other way? Yes, -1, -2, -3. So for the height of the man who's 6 feet 8 inches tall, I'd have to look up the standard deviation. I'd have to look up the mean for the height of men, and then find the z-score and find where he lands on that number line. And for the woman, the same thing. Find where she lands on that number line. And the one with the highest z-score is the taller one when we compare them to their groups. Here's the formula for z-score. Formula for z-score. I'll write z for z-score equals, it is the score minus the mean divided by the standard deviation. Now, if you want to use the symbols, I could say score is x, the mean is x bar, standard deviation SD. I might have mentioned last time, there's another symbol for the mean. It looks like a script U, x minus, script U, divided by the standard deviation. There's another symbol for standard deviation. It looks like a little sideways 6. I'll tell you what those symbols are, though. We don't read it script U. This is the Greek letter mu, mu is the Greek letter mu, lowercase. That one that I call the sideways 6 is the Greek letter sigma. The difference between x bar and mu, they're both the mean, but x bar is the mean if we have a sample. Mu is the mean if we've calculated the mean of a population. SD, I'll use that for standard deviation because when I took that statistics class in that PhD level statistics class, my teacher did that. So I said, well, that looks pretty good. Sigma is standard deviation if you've calculated the standard deviation of a population. So there's formula for z-scores. Let's do a couple of problems. I'm looking at number 23. You do have to learn the formula for a z-score. So my suggestion is going to be write it down every time you use this formula.